Tutorial 1, Ventilation. Okay, so there's 6 questions in this tutorial, so let's get on with it. So the first question is, name the suitable mechanical ventilation system to be installed in a kitchen. So basically it's asking you what sort of ventilation should be installed in a kitchen area. So a suitable system to be installed in a kitchen area is a natural inlet and a mechanical extract system. So why do you choose a natural inlet and a mechanical extract system? Because as you are cooking, there will be as you cook, there will be aromas, there will be gas, there will be these smells. So if as you cook, all these things are coming out into your room, you want a way to take out this smell or air from your room. That's why you want to have a mechanical extract system, which is this fan here. As you open this fan, it will bring out all this air, all this cooking smell from your cooking area out from the room. So that's why you want to have a natural inlet and a mechanical extract system in your kitchen area. So if you have a natural inlet and a mechanical extract system in place, which is here, you also want to have an air inlet, because if you do not have an area where air is coming in, you will not be able to extract the area efficiently out of the room. Okay, so on to the next question. So second question is asking, with the aid of an annotated diagram, illustrate mechanical ventilation using the mechanical extract and natural inlet system for an assembly hall. So it's asking you to explain how this mechanical extract and natural inlet system works for an assembly hall. So this is like a previous question, which is question 1, like the kitchen area is also using a mechanical extract and a natural inlet. Mechanical extract system and natural inlet here, as you can see. So okay, there's 3 points to this. The first is air is extracted out from the assembly hall through extractor, inlet, ducting, and fan. So this is the system, the component making out this ventilation system. So the second and third point is the important part. So if you can see here, there's a negative pressure and a positive pressure. So ventilation works in such a way that a mechanical extraction system is installed there to make these pressure differences occur. So here it says the pressure of the ventilated space become less than pressure outside the room, which is a negative pressure. And the next one says the higher pressure at outside will force the air into the negative space through the fresh air inlet or opening. So there's a picture here. So this is the same like the kitchen area. You have a mechanical fan which will pull out the air in the room. So this in terms will cause a negative pressure inside the room. So as the air is being pushed out, because the outside air have a higher pressure than the room inside, the air outside will actually push through any entrance, such as this entrance door corridor. The air from the outside will push through this air into this room. If there's a window, then the outdoor pressure, which is the air, will come into the room through that opening. So in this case, if you can see here, there's an entrance door and there's an inlet. So as this system is being on, air will be extracted to this duct, and then the air will flow through this ventilation system and out into the atmosphere, to the outdoor. And then because the outdoor have more pressure than the inside the room, then the air outside will into the room, will force itself into the room through any opening, such as this entrance door or the inlet grill. So this is how ventilation works. it works because it works by having differences of pressure. Okay, so on to the third question. So the third question is saying basically ventilation is a process of changing air in an enclosed space. So they are asking you how the air purity can be achieved. Briefly explain it. So air purity can be achieved by preservation of oxygen content and then removal of CO2, control of humidity, prevention of heat concentration, prevention of condensation, dispersion of concentration of bacteria, dilution and disposal of contamination, and provision of freshness. So, in a room, if we are standing there, as we breathe, we will be exhaling CO2. And then with our breath, we are also expelling heat and water vapor from our body. So that's why there's this removal of CO2, control of humidity, or prevention of condensation, which is condensation is the formation of water droplets due to our water vapor, and prevention of heat concentration because as we breathe out, our breath has a heat, and then dispersion of concentration of bacteria and dilution and disposal of contamination. So this bacteria and contamination, if we have a room and we do not regularly regulate the air, which we do not regularly expel out all this old air in the room, you imagine that bacteria, fungus, all these decomposing organism will breed. They will breed and they will try to break down anything in the room, such as the wood and such as wood, furniture, or anything that is organic in the room. So that's why you want to have regular change of air in the room. If not, then the room have a lot of dust. So with ventilation, you will be able to make the air clean. Okay, so this is why you want to have ventilation and how this air purity can be achieved through ventilation. Okay, so question 4 is asking what's the difference between natural and mechanical ventilation system of a building. So natural ventilation is economic because once you build a window, that's considered a natural ventilation. It uses wind to change the air in the room. So if you have a window and there's wind, which will cause changes of pressure from outside, having a high pressure blowing into the inside of the room, which is at the lower pressure, then you will be able to save in terms of your costing and operation cost because you will not have a motor there driving the fan to pull in the air into the room or to extract the air out of the room. So but mechanical ventilation system can provide positive ventilation at all times. So this is one thing good about mechanical ventilation. Natural ventilation is cheap, but in a case where you don't have natural wind, then there will not be any ventilation in your building, which is bad. For in a case where you would want to have ventilation at all times or at a times where you can control, you want to install a mechanical ventilation system. So next is with a mechanical ventilation system, you can actually install a filtration system. This way, when you have this sort of filter, when you're actually extracting the air in, or you'll be able to extract the clean air. So you'll be able to make sure there's no dust from the air going into your room. So this is one of the good thing with mechanical ventilation. But if you have natural ventilation, if you open the window, over time, you'll notice that there will be an accumulation of dust, because although you will not be able to see it as the wind blow and as it stops naturally, because wind do not blow all the time, then you'll notice that as time goes by, there will be fine dust all over the area. But with a mechanical ventilation system, you are actually able to install a filtration system so that all the air coming in is at least there's not so much dust. But one problem is mechanical ventilation system incur a high capital, because you need to have all this ducting, all the fan, all the motor. You need to be able to service the motor, and as you run this fan, you will have a recurring electricity cost. So each month you have to pay for it, and then in 1 to 2 years you have to do maintenance on it. So the difference between the natural and mechanical ventilation is mechanical ventilation system can provide positive ventilation at all times, but they are expensive to run and install. Natural is able to provide cheap ventilation due to it using the natural energy on our earth, and you do not need a lot of space, you do not need to service it. But natural ventilation depends on the wind condition. If there is no wind, then you will not have any ventilation for your room. Okay, so if you can see here, there will be a table showing the three categories for natural ventilation and mechanical ventilation. So in terms of cost, natural ventilation wins because you do not need to install any motor, so you do not have need any capital cost to have this sort of to use this sort of ventilation. What about efficiency? Efficiency, the winner will be the mechanical ventilation, because with the use of motor, you'll be able to have positive ventilation at all times. You can have an added advantage of adding a filtration system, means you can have a cleaner air. And then the next one is space requirement. So natural ventilation do not need any service space. So this service space which the mechanical ventilation require is all this ducting, all this fan, all this filtration system, damper system, fan. So natural ventilation is simple. You just have a window at opposite side of the room, left or right, or front and back, and then you have a easy and cheap natural ventilation for a room. Okay, so next question is 5. Figure below show a mechanical ventilation system servicing the two room. So it's asking you to name the ventilation system. So based on the figure, you are able to see there's a fan at A. And if you look at the inlet, there is just an opening. So this is a natural inlet and mechanical exhaust system. So the second part is name the component A, B, C, and D. So A is very obvious, it's a fan. B is the duct. C is the damper. And D is the diffuser. So fan is what you use to take out the air. You make the difference in pressure. You make the room low in pressure, and then with the high pressure from the outdoor, you'll be able to the fresh air will be able to force itself into the room. So here the function says fan, it can produce high air pressure and use for moving air through ductwork. And then B is your ductwork, which is a series of tube to transfer the air between spaces in building and fire damper. So this is installed to prevent fire burn through the wall opening, so as to control the rate of combustion. And diffuser, it is circular or square or rectangular. So this is just to distribute the air when it go outside. So this is the basic component for a ventilation system. So if you see here, it's pretty standard. You have a, for this is a mechanical extractor, which is at A, this is the fan, and then B is the body for moving the air out. So, and then you have a C. So C will, you will find C, this is a fire damper at the section where, at the wall section where there's a room A and room B, or in this case room 1 and room 2. So why do we need this? A fire damper's function is to prevent a fire from burning through to the next building. So you do not want to have a very good room here which is very fireproof, but you have an opening here which is not fireproof. So that's why you need this fire damper, so that in case a fire occurs in this room, the fire is just contained in this room. So if your wall can withstand 2 hours, you want to make sure your this fire damper can have a fire rating of 2 hours. If you have only 1 hour, then it's not advisable lah. You should upgrade it to match this room. In case a fire occur, it would not just simply spread through your this fire duct, through your this exhaust duct. So this is a function for a fire damper. Okay, so this is pictures how a diffuser, how an outlet works. So you'll be able to see this sort of diffuser outside. This is a square and rectangle diffuser. And then this is the also a diffuser, a square one. There will be a thermal sensor. Okay, this is a last question. So with the aid of the diagram, discuss the 4 basic refrigerant process with 2 distinct pressure areas in the cycle. So these are the 4 basic refrigerant process. The first is compression, condensation, expansion, and evaporation. So in compression, the refrigerant comes into the compressor as a low pressure gas. Then it compresses and then move out of the compressor as a high pressure gas. So a compressor basically compresses the refrigerant into a high pressure. So condensation, with condensation, the gas then flow to the condenser. Here the gas condenses to a liquid and gives off its heat to the outside air. Then expansion, so here the liquid will expand, and then evaporator, the low pressure liquid then move to the evaporator where heat from the outside air is absorbed and change it from a liquid to a gas. So there's 2 distinct pressure in a refrigerant, which is at low pressure and a high pressure. So low pressure is at expansion and evaporation, and high pressure is at compression and condensation. So this is an image of how a refrigerator works. Another diagram for it. So this is a image to show you how refrigerator works. So how these gases move from one cycle to another cycle, how they cool down your refrigerator. So it's a repeat cycle. There will be 2 areas, which is high pressure and low pressure. So they start off at a compressor. So the gas is compressed at a high pressure and they are moved to condenser. So this is where the heat is released from the condenser. Means the heat is absorbed at the evaporator and then is released out here. Then as they change the state, as the heat is being released, as it moves along, it will reach the expansion valve. Then it will move to the evaporator and then it will move in a cycle. So basically there's two states which this is important, which is high pressure and low pressure. So high pressure is at expansion and evaporation. High pressure is at compression and condensation, and low pressure is at expansion and evaporation. So there are 4 cycles. Okay, so that's about it for the tutorial.